Good day, everyone. In this lesson, we are going to learn on how to solve problems involving bounded growth and logistic growth. Now, let's start with the bounded growth problem. Now, to solve bounded growth problem, we use the equation y is equal to k minus c times e raised to the power of negative k times t, which is equal to k minus c times a raised to t, where k here is the carrying capacity and t is the time. Now let's have our first example. A certain per weekend breeding site is said to be able to sustain 5,000 per weekends. 1,000 per weekends are brought there initially. After a year, this increased to 1,100 per weekends. How many per weekends will there be after 5 years? Assume that per weekends follow the limited growth model. To solve this problem, our first step, okay, our first step is to define, the variables. Okay, so we need to define the variable y and t. So let, so we to let y, be the number, be the number of per weekends, be the number of per weekends, be the number of per weekends at any given time. Okay, so that's our y. Then t, t be the number, be the number of years. Since our t here is defined in years, so our t will be the number of years after, after the initial time, meaning after t is equal to 0. Okay, so that's our variable. Our y is the number of per weekends at any given time, and t is the number of years after t is equal to 0 or after the initial time. Okay, then our second step, our next step, our next step is to identify, we need to identify, the initial, the initial conditions, which is given in the problem, the initial conditions. Okay, so the given problem, we know, we know that at t, or the initial time, no, at t is equal to 0, 1,000 per weekends are brought there initially. So meaning at t is equal to 0, our y, meaning the number of per weekends, is equal to 1,000. Okay, so that's the first initial condition. And then the second is that, at t, since after a year, so meaning at t is equal to 1, then the number of per weekend increased to 1,100. So meaning our y is equal to 1,100. Okay, and then also take note that we have here the given k. So we know that k is the carrying capacity. It is given that the certain per weekend breeding site can only sustain 5,000 per weekend. So meaning the 5,000 here is the carrying capacity. So meaning k is equal to 5,000. Okay? Then for our third step, we need to solve, for the value of z. And to solve for the value of C, all you need to do is to plug in the first initial conditions and the value of K, which is our carrying capacity, okay, to our general solution for the bounded growth. Okay, and we know that our general solution for the bounded growth is y is equal to k, where k here is our carrying capacity, minus c times a, then raised to t, which is the time. Okay, so now plug in the first initial condition. So we have the value of y, which is equal to 1000. Okay, 1000 then equal to k, which is 5000. Okay, then minus c times a raised to 0, since our t here in the first initial condition is equal to 0. Okay, then solving for c, so here we have negative, so adding both sides by negative 5000, so we have negative 4000, okay, is equal to negative, okay, c, since a raised to 0 is just equal to 1. Okay, so now, all you need to do is multiply both sides by negative 1. So that gives you the value of c, which is equal to positive 4000. Okay, so that's the value of c. So our next step is to solve for the a. So solve for a. Okay, so we need to solve for a. So how to solve for a? So we need to use the second initial condition, okay, and the value of k and c, okay, and plug in into the general solution. So here we have y, so we have here the value of y, which is equal to 1100, okay, 1100 is equal to the value of k, which is 5000, okay, minus the value of c, which is 4000, okay, then times a, then raised to 1, since the t here is equal to 1. Okay, then let's simplify this one and solve for a. So first thing that we need to do is we add both sides by negative 5000, so that will give you negative, okay, negative 3000, okay, 3900, okay, which is equal to negative 4000, okay, 4008. So dividing both sides by negative 4000, so that will give you your value, the value of a, okay, the value of a, which is equal to, okay, which is equal to positive 39 over 40. Okay, so that's the value a. Since meron na tayong value ng c and a, okay, so our next step, okay, our next step is to, okay, is to write, okay, is to write the particular, okay, the particular solution, okay, the particular solution to the given problem. Okay, so again, to write the particular solution, we need to use the general solution and plug in the value of k, c, and a. Okay, so now we have the general solution, y is equal to k minus c times a raised to the t. So all we need to do is plug in the value of k, c, and a into this equation. So we have y is equal to k. Our k is 5000, okay, then minus the c, which is 4000, then times 39 over 40, okay, then raised to. So this is now the particular solution for the number of Powicans at any given time. Now for our final step, okay, we need to answer the question, how many, okay, how many Powicans, okay, how many Powicans will there be, okay, will there be after, okay, after 5 years? Okay, and to answer this question, all we need to do is use the particular solution, then plug in the value of t. Okay, so that means at t, okay, at t is equal to 5, okay, the number of per weekend is y is equal to 5,000 minus 4,000, okay, 4,000 times 39 over, okay, over 40, then raised to, okay, raised to 5. Okay, then using our calculator, so we have 5,000 minus 4,000 times 39 over 40, okay, then raised to the power of 5. Okay, so that is, okay, so that is approximately equal to 1,476. So we need to round off that one to the nearest whole number. So that means it is approximately equal to, okay, so that is approximately equal to 1,476. Okay, so therefore, for our conclusion, okay, so for our conclusion, thus, okay, so thus, there will be, okay, there will be, okay, there will be approximately, okay, approximately 1,476, okay, 476 per weekends, okay, per weekends after, okay, after 5 years. And that's the answer to the given